Hello Internet! You may be asking yourself, why does this idiot have an Arduino strapped to his hand? To which I reply, that's not very nice. But also, it's a way to show you how to use a motion sensor so you can add gestures to some of your microcontroller projects, particularly if you have like some props or costumes and you want to be able to raise your hand and have some effects triggered. Here's a way you can do it using this little guy. So this is the MPU6050 gyroscope and accelerometer. You see, it's only about $2 on eBay, so it's really, really cheap. And you only need 5 pins to connect it, as you can see here. And just to make sure that A4 and A5, those are that second row of pins on the Arduino Pro Mini, not the ones on the edge, just make sure. And then you connect the INT pin around the back to pin number 2. Once you got that going, you're ready for the next step. So we have to install a couple of libraries in order to talk to the MPU6050 module. To do that, let's go to GitHub. You need to download this zip file. Navigate to the Arduino folder, and we're going to grab the I2Cdev folder, and of course the MPU6050. Drag those into your libraries folder, and then fire up your IDE. Now we go to File, Examples, MPU6050, and hit up the raw. Make sure that your COM settings and your board is set up properly, and then upload. Now that that's done, hit up the serial monitor, and boom. Great, you've got some output. You can totally read that, right? Yeah, neither can I. So in the next step, we're going to make that a little prettier and easier to understand. But first, we have to get a little ugly in the command line. So to get ready for the next step, we need to install a couple of things. First of them is Node.js. Go ahead and grab version 692 and run through the installer. I've already installed it, so I'm going to skip this. Next, we have to go back to GitHub, and this time you're going to download one of my repos. This is a tool I built just to help me out with this accelerometer, and hopefully it'll help you out too. Go ahead and extract that wherever makes sense to you. I'm going to leave it in the download folder. Navigate to the SerIOGrapher folder until you are looking at the README and the ACC. Now what you want to do is, on Windows, hold down Shift and right-click on that parent folder, and you get an option here for Open Command Window. So we are going to be installing 4 packages to help this program work. So go ahead and type this in, let it run. Once that's done, you should be able to type node and that ACC serial and then -L. And that is going to list your serial port, which is important. So in this case, for me it's COM3, and I set that as a default. So if it's also COM3 for you, you're good. If not, when you run this tool, you're going to need to specify with P the number. And this is going to prepare us for the next step. Now go to the Arduino folder, and we are going to choose raw uncalibrated. So open this up in your IDE and upload it to your Arduino. Now go back and make sure that you don't have any serial monitors still running, like this one. Go ahead and kill that. Let's navigate back to the public folder, grab this, drag it over, and again, we're going to open command window, node. Again, I'm using port 3. You need to change this to whatever is appropriate for you. And now we've got a pretty graph. So now, as you can see, as I move my hand, we get different actions in the accelerometer. So what you saw there was the raw output from the accelerometer, and it's a little choppy and noisy, and it's going to be hard to work with inside the microcontroller, so we're going to smooth it out. So lucky for you, I've done this work for you. Go back to the Arduino folder and look for the smoothed file. Also, close this tool because that's going to prevent you from uploading, and then upload. And now just restart that server. Now if you start moving around, you see that you have significantly more smoothed out lines. The way this is working, if you look into the code, it's doing what's called a running average, taking a history of about 25 or so points and averaging them into the current output. And this is going to be something that we can finally work with inside the Arduino. So here's the fun part, actually mapping our gesture. So if we wanted to make a gesture from going flat to vertical, we can see how the graph changes accordingly. But it's kind of hard to work with as the graph is streaming by us, so we're going to make a snapshot of the graph. So if you hold your first position and then raise to position number 2, go ahead and hit the snapshot button. And now, when you take your mouse and trace across the graph, you can see the values. And we're going to take those values and plug it into the Arduino. So now go back to the Arduino folder and open up the accelerometer states, but this time we're going to open it up in an editor. So the way that we actually detect the movement of the accelerometer and actually get gestures is by breaking it up into a bunch of states, a series of states that make up that movement. And so in my case, moving from flat to vertical, the way that I'm doing it is creating 2 methods that each check for that particular state. So the flat state, the vertical state, and then the sequence is checked under was lifted, and this returns true if we went from flat to vertical, and then I'm just setting a variable glowing to turn on a light sequence. So here in check flat, you can see that we are checking for is that Z is greater than 1500 plus or minus. That's what we're doing with the absolute value. And that I'm allowing a little bit of wiggle room in the y-axis so that it can be plus or minus up to 5100. And this is because as careful as you are, you may never be 100% super steady when you're holding this. So if you add a little bit of padding and wiggle room, it'll allow you to reach that state that you're looking for without being super precise. And then we just record some information. When the condition started, when it last ended, and the duration. And you can see we're doing something similar in check vertical, only the states we're looking for are a little bit different. Again, in this case, we're doing some padding so that we are between plus or minus 8,000 in the Z and the X, and in the Y, specifically, we want to be more negative than 13,500. And depending on the states that you're looking for, you just use the graph, figure out the ranges that you're working in, and then plug them back. And in our wasLifted function, we're just stringing together these sequences. So we're looking for, is it vertical now? How long did it last? In this case, I'm looking that the vertical state should be at least 200 milliseconds. And then how long has it been since we were resting flat? If we were less than a second, that's what I'm looking for. If it took too long to go from horizontal to flat, in my case, I want to throw that out. For instance, if you're leaving the microcontroller or the project on a table and you just lift it up, you don't necessarily want to have that included. It should be more deliberate so that you quickly move through the rest of the gesture. And then the final states are that the flat duration was at least 250 milliseconds, but no longer than 2.5 seconds. And that's what I was stating before. If it's sitting flat for too long, it's not necessarily important for my case. And so we just return true. And then once wasLifted returns true, we trigger the lights on. And so there you have it, guys. Once you get that sketch compiled and uploaded to your Arduino, you can do cool stuff like this. I originally put this project together because I was having a hard time finding any information online for actually working with microcontrollers within the Arduino. There was so much stuff that I found about taking the data, the sensor data, and outputting it to a computer or for graphing in other places, but nothing that just sat as a self-contained project. So I'm hoping you find this useful and you use it in some cool stuff. Please leave a comment down below if you actually do put this to use somewhere. I'd love to see some of your projects. But until then, live long and prosper. It broke. There we go. Bye, guys.